In this video, we will continue to practice solving trig equations such as this one. We've already done problems 1 through 5 on the previous video, so if you did not watch that, you might want to go back and check it out. Make sure you know these Pythagorean identities by heart. All right? Be able to take a sheet of scratch paper and write all of these down exactly the way they look. Also, make sure that you've memorized these facts. Okay, so I'm going to want to factor this. I need 0 on one side, so I'm going to subtract 1. So that's going to give me 2 cosine squared x minus cosine x minus 1 is equal to 0. So now I'm ready to factor. This first term can only factor as 2 cosine x times cosine x. Then I see this number 1. That can only factor as 1 times 1. Now I do inner plus outer equals middle. Inner, I have 1 cosine x. Outer, I have 2 cosine x. That must equal the middle, where I have negative 1. So let's see, if I have a positive 1 and a negative 2, whoops, didn't mean to put a second 2. If I have positive 1 and a negative 2, that will make negative 1 cosine x. So that means this is a positive 1 and this will be a negative 1. Okay, check one more thing. Does positive 1 times negative 1 equal negative 1? Yes. So we have factored correctly. So now I will set the two factors equal to 0. So 2 cosine x plus 1 is equal to 0. And cosine x minus 1 is equal to 0. Adding 1 to both sides, I get cosine x is equal to 1. Subtracting 1 and dividing by 2, I get cosine x is equal to negative 1/2. So, time to ask myself what the solutions are. So first I need to decide what the reference angle is. Okay, so in my mind, I'm doing this. Ignore the negative sign. Cosine of what is 1/2? That is pi over 3. Cosine of pi over 3 is 1/2. So the reference angle is pi over 3. So that makes this, pi is the same as 3 pi over 3. And 2 pi would be the same thing as 6 pi over 3. All right, thus I'm doing everything using the reference angle of pi over 3. So I want cosine to be negative. So think about what two quadrants cosine will be negative. Cosine will be negative on the left side. So that's going to be here and here. All right, the left side. So that is before and after 3 pi over 3. So that's how I know that I will have 2 pi over 3 and 4 pi over 3. All right, it's just before and after 3 pi over 3. So I don't normally draw this picture. That was just for instructional purposes, but you should be able to easily picture this in your mind because the numbers are so simple. Now, switching over to the green one, where is cosine equal to 1? Well, that is a quadrantal angle. Cosine is an x value. X values are equal to 1 on the far right, and that is 0. So I will take this and I'll add on 0. So these are the three answers to problem number 6. I am not happy with the fact that I have two different kinds of trig functions, sine and cosine. So I am going to use my trig identities. I know that sine squared is 1 minus cosine squared. So I'm about to make that substitution. So I will have 2 times 1 minus cosine squared x, because of the 2, equals 2 plus cosine x. Now it's all cosine. I like that better. I'll have to do the distributive property here. So that's going to be 2 minus 2 cosine squared x is equal to 2 plus cosine x. So I will need to subtract 2 from both sides. I'm getting 0 on one side. And I will subtract cosine x from both sides. Okay, these are going to cancel each other out. So then I will just bring down the rest of this. So I'll have negative 2 cosine squared x minus cosine x is equal to 0. Okay. I am going to take out a GCF of, well, you know what? First of all, I don't like the fact that it's negative. So I'm going to multiply both sides of the equation by negative 1. So that's going to give me positive 2 cosine squared x plus cosine x is equal to 0. Now I'm going to take out the GCF. I see cosine twice. So cosine x is a common factor. Pull that out. That's going to leave 2 cosine x plus 1. Set these factors equal to 0. All right, so I'll have 2 cosine x plus 1 is equal to 0. And I will have cosine x is equal to 0. Where does cosine equal 0? I'm picturing the quadrants. Cosine is an x value. X values are 0 right on the y-axis. So that's going to be pi over 2 and 3 pi over 2. Okay, now if I subtract 1 and divide by 2, that's going to give me cosine x is equal to negative 1/2. Okay, now that is a reference angle of pi over 3. Ignoring the negative sign, I know that cosine of pi over 3 is 1/2. So the reference angle is pi over 3. So I'm thinking, right here is 3 pi over 3, and right here is 6 pi over 3. We want cosine to be negative, so that means it needs to be in the second or third quadrant, here and here. That's before and after 3 pi over 3. So that's going to be 2 pi over 3 and 4 pi over 3. So those are the 4 answers. For number 8, luckily it's all one kind of trig function. It's all sine. So all I have to do is add 1 to both sides. So I've got 2 sine squared x minus 3 sine x plus 1 is equal to 0. And it's time to factor right away. So first term, 2 sine squared can only be 2 sine x times sine x. Skip to the third term, 1. 1 can only be 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 sine x. Outer, if I multiply these, I have 2 sine x. The middle is negative 3. Negative 3 sine x. I will only get that if both of these are negative. So that means both of these have to be negative. Negative 1 times negative 1 is positive 1, so that's good. Now, setting the first factor equal to 0, I have 2 sine x minus 1 is equal to 0. Adding 1 and dividing by 2, I have sine x is equal to 1/2. The reference angle is pi over 6, because I know that sine of pi over 6 is 1/2. Whoops, wrong button. So in my mind, I'm picturing this. The reference angle is pi over 6. So on the left side, that would be the same thing as 6 pi over 6. And on the right side, 2 pi is the same thing as 12 pi over 6. We want sine to be positive. All right, sine is a y value. So it will be positive in the first quadrant and in the second quadrant, all right, above the x-axis. So these are the two that we want. So of course the first one is simply pi over 6, you know, the reference angle itself. So we've got pi over 6. The next one is just 1 short of 6 pi over 6. So that's 5 pi over 6. All right, if you picture it that way, you should be able to do it without drawing the picture. All right, you should be able to do it in your head. Okay, on the other side, we have sine x minus 1 is equal to 0. Adding 1 to both sides, I have sine x is equal to 1. All right, so for this, I'm picturing the quadrantal angles. Sine is a y value. The y values will equal 1 at the very top of the unit circle. And that's why I will add on a solution of pi over 2. So these are the 3 solutions for problem number 8. I'm liking number 9 because it's full of only cosine, and I even have 0 on one side. So we can go straight to the factoring part, which is kind of my favorite in a nerdy way. 2 cosine x squared can only factor as 2 cosine x times cosine x. Then I jump over and look at the 1. That can only be 1 times 1. Then I think inner plus outer must equal the middle. Inner, I have 1 cosine x. Outer, if I multiply, I have 2 cosine x. The middle is positive 1 cosine x. So I need a negative 1 and a positive 2 to make positive 1. So that means this is going to be negative and this is going to be positive. Now I set the factors. Let me just sort of box that out. Now I set the factors equal to 0. So I'm going to go 2 cosine x minus 1 equals 0, and I'm going to go cosine x plus 1 equals 0. Add 1, divide by 2, I get cosine x is equal to 1/2. Subtracting 1, I get cosine x is equal to negative 1. Looking at this guy, the reference angle has got to be pi over 3. So where is cosine positive? So in my mind, this is what I'm thinking. All right, and you should be able to do this in your brain without drawing it the way I am. But I know that cosine is positive on the right-hand side of the unit circle. In other words, cosine is positive in the first quadrant and in the fourth quadrant. Okay, above and below this mark right here. Since my reference angle is pi over 3, on the left side this would be 3 pi over 3, and right here would be 6 pi over 3. Alright, so these two angles are pi over 3 is one of them. Can I go down here? One of them is pi over 3. Alright, that's the one at the top. Now the one at the bottom is going to be 5 pi over 3. Alright, just one short of 6 pi over 3. So 5 pi over 3. Now, for this one, where is cosine equal to -1? Well, cosine is an x value, and x values are equal to -1 right here. So that's pi. So those are the three solutions. I'm less happy about problem number 10 because it has cosine and sine. I need to fix that. I'm going to tack this cosine squared using my identities. I know that cosine squared is equal to 1 minus sine squared. So I'm going to make that substitution, and this will become 1 minus sine squared x plus sine x is equal to 1. Maybe I'll go ahead and sneak in and subtract 1 from both sides real quick. So I'll go ahead and get minus 1 is equal to 0. Now I'm hoping you can see that the 1 and the -1 are going to cancel each other out. 1 minus 1 is 0. So that's just going to leave me with negative sine squared x plus sine x is equal to 0. I don't like it when the leading coefficient is negative, so I'm going to multiply both sides of the equation by -1. So that's going to change this to positive sine squared x minus sine x is equal to 0. Now it's time for the GCF. Sine x is a common factor, so I'll pull that outside of parentheses, and I will have sine x times sine x minus 1. Alright, now I'll set each of these factors equal to 0. So sine x equals 0 and sine x minus 1 equals 0. Adding 1 to both sides, I discover that sine x is equal to 1. Now where does that happen? That happens at, well, sine is a y value. Alright, I'm seeing where I can have space to do this. Sine is a y value. So I know that a y value would be positive up here at the top. So that's pi over 2. Now where is sine 0? Y values are 0 right on the x-axis. So that would be 0 and pi. So I'll have 0 and pi. So together, these are the three answers to problem number 10. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.